Section 10.2 is about the angles relating to parallel lines. Let us first of all learn some vocabularies. In the figure, you can see that a line intersects the other two lines. For each intersection, there are 4 angles formed. As a result, there are 8 angles formed. We call the line intersecting the other two lines the transversal. A and E are called a pair of corresponding angles. So in the figures, there are 4 pairs of corresponding angles. We also have B and F, C and G. The last pair are D and H. The next type of angle is called alternate angles. In the figure, there are only 2 pairs of alternate angles. They are D and F. The next pair is C and E. You can see that D and F are on the different side of the transversal. Also, C and E are on the different sides of the transversal. Also, they are inside the 2 given lines. So, these are the characteristics of alternate angles. The last type is called interior angles. On the same side of the transversal. Just like the alternate angles, we refer to the angles within the 2 given lines. So in this case, D and E are in the interior angles on the same side, and other pairs is C and F. So based on the above definition, we will not say A and H are interior angles on the same side. Another example, we will not say that B and H are alternate angles, so be careful. Now if the two intersecting lines intersecting the transversal are parallel, then we will have the following result. First, we know that if A and B are corresponding angles, then they are equal. To see why, we can move AB to overlap CD, and then you can see that A and B should be equal. So let me write down the theorem. If AB parallel to CD and A and B are corresponding angle, then A is equal to B. The reason we say is corresponding angles. AB parallel to CD. Note that if AB is not parallel to CD, we cannot say that A and B are equal. Let's see an example. In exercise 10 question number 10, you can see that M and 72 degrees are corresponding angles. Also, AC and EF are parallel. So we can write M is equal to 72 degrees. And the reason is corresponding angles. AC parallel to EF. Surely you can use EG instead of EF. To find N, we should use another pair of parallel lines. We can write N is equal to M. Note that you must write M, not 72 degrees, because N and the given 72 degrees are not directly related. In order to avoid confusing, you have to write the original name of M. Here the reason is similar. We write corresponding angles. This time we should write AB parallel to CD. Therefore N is 72 degrees. The next theorem is about alternate angle. In the figure, if AB and CD are parallel, and angle A, angle B are alternate angles, then we can say that A and B are equal. To see why, we can add another angle, X, opposite to angle A. By corresponding angles, we know that B is equal to X. Also, A and X are equal by vertically opposite angles. As a result, A is equal to B. The reason when using this theorem is alternate angles AB parallel to CD. To see how to use the theorem, let's do question number 8 in exercise 10.5. In the figure, we can write angle DCB equal to 30 degrees by alternate angles CD parallel to AB. Also, B plus angle DCB is 180 degrees by adjacent angles on straight line. So B plus 30 degrees is 180 degrees and B is 150 degrees. The last theorem in this part is about the interior angle on the same side of the transversal. We write if AB parallel to CD, then A plus B is 180 degrees. Note that this time they are not equal. It's clear to observe from the diagram that angle A and angle B should not be of the same size. To see why this theorem is true, we can add an angle X. So X is equal to B by corresponding angles AB parallel to CD. Also, X plus A is 180 degrees by adjacent angles on straight line. Therefore, B plus A should be 180 degrees. To use the theorem, we write the reason as interior angles AB parallel to CD. See an example in exercise 10 question number 3. The diagram shows that PR and QS are parallel. As a result, angle RPQ plus angle PQS is 180 degrees by interior angles PR parallel to QS. So 105 degrees plus K plus 55 degrees is 180 degrees. K plus 160 degrees is 180 degrees. K is 20 degrees.